Hello, so today we're going to learn about momentum and impulse, trying to understand how to solve the problems regarding these two topics and making sure we understand the concept around it. Okay, so now we have a statement here which says that Tom, with a mass of 65 kilograms, slips on a mountain path and falls 5 meters vertically downwards. So luckily he lands on a 100-kilogram boat which is moving along the river directly below the path. So the first thing you're going to do is going to write the information of the statement given. We know that we have Tom, who has a mass of 65 kilograms, and a boat with a mass of 100 kilograms. So if we were to draw the illustration of what's happening here, is we have Tom on top of this mountain here, right? And we are told his mass is equals to 65 kilograms. So what you need to note is that his initial velocity is going to be 0 meters per second because he just slips on this mountain path, right? He doesn't jump. So from this point onwards he falls vertically downwards. So luckily he lands on a boat, right? So this is him. And then we know very well that the boat has a mass of 100 kilograms. So it's very important that we note this down so that we are able to answer the questions that follow. The question says that the boat was moving at a constant velocity of 5 meters per second when Tom fell on it. So this is very important. So meaning that its velocity was equal to 5 meters per second. So now calculate the velocity of the boat and Tom directly after Tom fell on it. So what you need to note that is, okay, fine. We now focus on Tom and boat system, right? So what we're going to do is we're going to calculate the momentum, calculate the sum of the momentum of the initial, so before Tom fell on the boat, and the sum of the momentum of the final, so when Tom was already in the boat. So we know real that the equation of momentum is P is equals to mv, which this means the mass, and this is the velocity, right? So we're going to include the initial momentum of both systems. So we have mv of Tom plus mv of the boat. The initial one is equals to mv of Tom for the final plus mv of the boat final, right? So what you're going to do here is, what you need to note is that after Tom has now been inside this boat, so him and the boat become one system. So meaning that they will have the same velocity. So it's important that we combine these two here. So that's what you're going to do. Just going to factor out the velocity. So we're going to have mvti plus mvbi is equals to m of Tom plus m of boat, all the velocity final of both the boat and Tom, right? So what is the mass of Tom? We know from this diagram here that the mass of Tom is 65 kg, but his initial velocity was 0, plus the mass of the boat, seen from the diagram, is 100, and its velocity, we were told, just as Tom was about to land on it, it was 5 meters per second. So and then here we're just going to include the 65 plus the 100 and the V final of both Tom and the boat, right? So and then now, so because it's 65 multiplied by 0, it's just going to be 0, né? Equals to 0. And then you want to take this one, so it's 100 multiplied by 5, which is equals to, so I'm going to add these two here. 100 plus 65 is going to be 165 velocity final, and then we multiply this, it's going to be 165 V final is equals to 100 multiplied by 5, which is 500. Then we divide by 165, and then the V final is going to give you 3.03 meters per second. So this is going to be the velocity of the system combined just after the collision, or after Tom has landed on the system, the Tom and boat system. So the second question says that the boat collides, so the boat collides with a rock in the river just after, so this is very important, just after Tom fell into the boat. So the boat comes to rest in 0.2 seconds. So again, we're just gonna first include our information, which is that, so the boat collides with the rock, so that's very important to note, and that happens just after Tom fell on the boat. Note that just after Tom fell on the boat, the velocity of the system, which we calculated in the previous question, was 3.03 meters per second. And another thing we're going to take here is that the boat comes to rest in 0.2 seconds. So meaning that yes, its V initial was 3.03 meters per second, then its V final is going to be 0 meters per second, right? So that's what you can take. So if you were to draw a scenario here, so this is the boat, right? And this is Tom. So this boat collides with this rock here. So it collides with this rock here. So as it collides, because this boat is moving in this direction, the rock will cause a force in the opposite direction. So there'll be a force here, which is opposing the motion of the boat. So now this whole thing will take time of 0.2 seconds until this boat comes to rest, right? So the question says that calculate the average force that the rock exerts on the boat. So as I said in this illustration here, so we're going to use the equation of an impulse, where it's F multiplied by change in T is equals to change in P, which is change in momentum, right? So we have our, so this is just going to be mv, right? So m change in v, which it's going to be the mass of the system, both Tom and the boat, and then we're going to have v final, which is going to be 0 as I indicated, minus v initial, which is going to be this 3.03, and then we're gonna put in the 0.2 here of the time. So if you write it nicely, we're gonna have F change in T is equals to M change in V, which is equals to, okay, which is just going to be force is equals to M change in V over change in T, which the M is the combination of the mass of Tom and the boat, which is 165, and then the V final is 0 minus the V initial, which is 3.03. So remember, the minus is just part of the equation. You know, when you write the change in velocity, it's V final minus V initial. So this is just general knowledge divided by time of 0.2 seconds. So what I'm getting here is minus 2499.75 newtons. So this will be the force, this force that I indicated here, the force that collided, or the force of the block, which is the rock, that pushed the boat. So yeah, we are done with this question. Thank you for watching the video. Don't forget to subscribe and write your comments down below.